Hello. Today's topic of lecture is Calculus of Several Variable Part 1, that is Composite Function and Chain Rule. I am S.R. Gaikwad, Assistant Professor in Department of Mathematics, Arts, Commerce, Science College, Yaval. Please subscribe my YouTube channel Parisram Maths Academy. Now first, composite function. Definition of composite function. Let u equal to f in bracket x comma y be a function of two variable x comma y, where x equal to phi of t, y equal to psi of t are functions of t. Then f in bracket x comma y is called composite function of t. Now here u is function of x and y are functions of t. Then such function f is called as a composite function of t. Next, chain rule. Let u equal to f in bracket x comma y be differentiable function of two variable x and y, and x equal to phi of t, y equal to psi of t are differentiable functions of t. Then du by dt equal to dou by u by dou by x into dx by dt plus dou by u of dou by y into dy by dt. Here u is differential function of two variable x and y both are differential function of single variable t, and therefore derivative of u with respect to t nothing but partial derivative of u with respect to x into dx by dt plus partial derivative of u with respect to y into dy by dt. This chain rule first, then chain rule second. If w equal to e of in bracket u comma v be a differential function of two variable u and v, and u equal to phi of x comma y, v equal to psi of x comma y are differential functions of x and y, then dou by w by dou by x equal to dou by w by dou by u into dou by u of dou by x plus dou by w by dou by v into dou by v of dou by x, and dou by w by dou by y equal to dou by w by dou by u into dou by u of dou by y plus dou by w by dou by v into dou by v of dou by y. These are partial derivative of function w with respect to x and y. Here w nothing but a function of uv and uv nothing but a functions of x and y. Then chain rule third. If e of in bracket u comma v comma w be differential function of three variable u comma v comma w, and u v w are differential functions of x comma y comma z, then here e of is function of u v w are functions of x y z. We can find derivative of function f with respect to x, with respect to y, with respect to z partially are given by dou by f by dou by x equal to dou by f by dou by u into dou by u of dou by x plus dou by f by dou by v into dou by v of dou by x plus dou by f by dou by w into dou by w by dou by x. This partial derivative of function f with respect to x. Similarly, dou by f by dou by y equal to dou by f by dou by u into dou by u of dou by y plus dou by f by dou by v into dou by v of dou by y plus dou by f by dou by w into dou by w by dou by y. This partial derivative of function f with respect to y, and dou by f by dou by z equal to dou by f by dou by u into dou by u by dou by z plus dou by f by dou by v into dou by v by dou by z plus dou by f by dou by w into dou by w by dou by z. This partial derivative of function z, function f with respect to z. These are three chain rules. We can take examples. First example, if z equal to e of in bracket x comma y equal to x square plus y square, comma x equal to t square plus 1 and y equal to twice t, find dz by dt. Solution. Let z equal to f of x comma y equal to x square plus y square be a function of x and y, and x equal to t square plus 1, y equal to twice t. That is, here z is function of x and y are functions of t. First, you can find derivative of z with respect to x. Z is function of two variable x and y. Therefore, we can find partial derivative of z with respect to x and with respect to y. And the partial derivative of function z with respect to x nothing but dou by z by dou by x equal to derivative of x square is twice x, derivative of y square is 0. But value of x is t square plus 1, and therefore twice x equal to 2t square plus 2. Derivative of z with respect to y. Derivative of x square is 0, derivative of y square is twice y. But value of y is twice t, and therefore 2 twice y equal to 4t. That is dA by z by dA by y equal to 4t. Now x equal to t square plus 1, y equal to twice t, and therefore dx by dt equal to twice t, because derivative of t square is twice t, derivative of 1 is 0, and dy by dt equal to 2, derivative of twice t is 2. And therefore here z is function of x and y, x and y are functions of t, and therefore by chain rule dz by dt equal to dA by z by dA by x into dx by dt plus dA by z by dA by y into dy by dt. Now dA by z by dA by x nothing but 2t square plus 2 into dx by dt is twice t. dA by z by dA by y equal to 4t into dy by dt is 2. Then we can simplify it. We get 4t raised to 3 plus 4t plus 8t, that equal to 4t raised to 3 plus 12t, nothing but derivative of function z with respect to t. Okay. Next example. If z equal to f of x comma y equal to x cube plus y cube comma x equal to a cos of t, y equal to b sin of t, find dz by dt. Solution. Let z equal to f of x comma y equal to x cube plus y cube be a function of x and y, and x equal to a cos of t, y equal to b sin of t. Here z is function of x and y. First you can find derivative of z with respect to x and with respect to y partially, and therefore dA by z by dA by x equal to derivative of x cube is 3x square, derivative of y cube is 0, and therefore 3x square equal to 3 into value of x is a cos of t, and therefore 3 into a cos of t bracket square, that is 3a square cos square t. dA by z by dA by y equal to derivative of z with respect to y, derivative of first term is 0, derivative of y cube is 3y square equal to 3 into value of y is b sin of t, and therefore 3 into b sin of t bracket square, that is b square into sin square t, and therefore dA by z by dA by y equal to 3b square sin square t. Then we can find derivative of x with respect to t and derivative of y with respect to t, and therefore dx by dt equal to derivative of cos of t is minus sin of t, that is minus a sin of t, and derivative of y with respect to is b cos of t, and therefore here by chain rule dz by dt equal to dA by z by dA by x into dx by dt plus dA by z by dA by y into dy by dt. And therefore dz by dt equal to dA by z by dA by x equal to 3a square cos square t into dx by dt is minus a sin t plus dA by z by dA by y is 3b square sin square t into dy by dt is b cos of t. Then we can simplify it from both. We can take 3 cos of t into sin of t as common. In first term a square into a, that is minus a cube sin of cos of t plus second term b cube sin of t, and therefore dz by dt equal to 3 into cos of t into sin of t into in bracket b cube sin t minus a cube cos of t is a required answer. Okay. Third example. If z equal to f of x comma y, where x equal to e raised to u plus e raised to minus v and y equal to e raised to minus u plus e raised to v, show that dA by z by dA by u minus dA by z by dA by v equal to x into dA by z by dA by x minus y into dA by z by dA by y. Solution. Let z equal to f of x comma y be a function of x and y, and x equal to e raised to u plus e raised to minus v, y equal to e raised to minus u plus e raised to v. Therefore, we can find derivative of x with respect to u and v. Derivative of x with respect to u, derivative of e raised to u is e raised to u, derivative of second term is 0. Derivative of x with respect to v, derivative of first term is 0, derivative of e raised to minus v is minus e raised to minus v. Derivative of y with respect to u, derivative of e raised to minus u is minus e raised to minus u, derivative of second term is 0, and derivative of y with respect to v nothing but derivative of first term is 0, derivative of e raised to u is e raised to u, and therefore here z is function of x and y are functions of u and v. Then we can find derivative of function z with respect to u and v, and therefore by chain rule first we can find derivative of z with respect to u. It means dA by z by dA by u equal to first derivative of z with respect to x into derivative of x with respect to u plus derivative of z with respect to y and then derivative of y with respect to u. And therefore dou by z by dou by x into dou by x by dou by u plus dou by z by dou by y into dou by y by dou by u. Then we can substitute the value of dou by x by dou by u and dou by y by dou by u. And therefore dou by z by dou by x into e raised to u plus dou by z by dou by y into e raised to minus u. Then dou by z by dou by v equal to dou by z by dou by x into dou by x by dou by v plus dou by z by dou by y into dou by y by dou by v. We can substitute the value of here dou by x by dou by v and dou by y by dou by v. We get dou by z by dou by x into minus e raised to minus v plus dou by z by dou by y into dou by y of dou by v is e raised to v. And therefore dou by z by dou by u minus dou by z by dou by v equal to, you can substitute the value of dou by z by dou by u and dou by z by dou by v, which are nothing but dou by z by dou by x into e raised to u plus dou by z by dou by y into minus e raised to minus u minus dou by z by dou by x into minus e raised to minus v plus dou by z by dou by y into e raised to v. Simplify. From this first term of both bracket, we can take dou by z by dou by x as common in bracket e raised to u minus minus plus e raised to v. From second term of both bracket term, we can take minus sign common. Also dou by z by dou by y common. In bracket remains here e raised to minus u and second bracket remains here e raised to v. That is e raised to minus u plus e raised to v. But e raised to u plus e raised to minus v from the given function, this term nothing but x and this term nothing but y, and therefore minus x into dou by z by dou by x minus y into dou by z by dou by y is required solution. Next, if u equal to f of x comma y, x equal to r cos of theta, y equal to r sin of theta, then show that dou by u of dou by x bracket square plus dou by u of dou by y bracket square equal to dou by u of dou by r bracket square plus 1 upon r square into dou by u of dou by theta bracket square. Solution. Let u equal to e of in bracket x comma y be a function of x and y, and x equal to r cos of theta, y equal to r sin theta. Here u is function of x, y are functions of r and theta. First we can find derivative of x and y with respect to r and theta, and therefore dou by x by dou by r equal to derivative of r cos theta with respect to r is cos theta. Derivative of y with respect to r, derivative of r sin of theta is sin of theta. It means dou by y of dou by r equal to sin theta. Then dou by x by dou by theta equal to derivative of x with respect to theta. It means derivative of cos of theta, which is minus sin theta, and therefore minus r sin theta. And derivative of y with respect to theta nothing but r into derivative of sin theta is cos theta. And therefore here u is function of x and y are functions of r and theta, and therefore by chain rule dou by u of dou by r equal to dou by u by dou by x into dou by x by dou by r plus dou by u of dou by y into dou by y by dou by r. But dou by x by dou by r nothing but cos theta, and dou by y of dou by r is sin theta. Putting this value, we get dou by u by dou by r equal to cos of theta into dou by u of dou by x plus sin of theta into dou by u of dou by y, which is equation 1. Then we get derivative of u with respect to theta, and therefore dou by u of dou by theta equal to dou by u by dou by x into dou by x by dou by theta plus dou by u of dou by y into dou by y by dou by theta. Then we can substitute the value of dou by x by dou by theta and dou by y by dou by theta. We get value of dou by x by dou by theta is minus r sin of theta into dou by u of dou by x plus r cos of theta into dou by u of dou by y. We can divide this equation by r, and therefore 1 upon r into dou by u by dou by theta equal to minus sin of theta into dou by u of dou by x plus cos of theta into dou by u of dou by y, equation number 2. And therefore from equation 1 and 2 dou by u of dou by r bracket square plus 1 upon r square into dou by u of dou by theta bracket square equal to the value of dou by u of dou by r is from equation number 1 cos of theta into dou by u of dou by x plus sin of theta into dou by u of dou by y bracket square plus value of 1 upon r square into dA by u of dA by theta bracket square. From equation number 2 we get minus sine of theta into dA by u of dA by x plus cos of theta into dA by u of dA by y bracket square, taking the bracket square expansion. The first bracket square expansion is cos of theta bracket square into dA by u of dA by x bracket square plus middle term 2 times sine theta cos theta into dA by u of dA by x dA by u of dA by y plus square of second term is sine of theta bracket square into dA by u of dA by y bracket square plus second bracket square expansion is sine theta bracket square into dA by u of dA by x bracket square middle term minus 2 times sine theta cos theta into dA by u of dA by x into dA by u of dA by y plus second term square nothing but cos theta bracket square into dA by u of dA by y bracket square. Then we can simplify it. These middle two terms are cancelled. From the first term we can take dA by u of dA by x common. Here we can take dA by u of dA by y as common. We get cos square theta plus sin square theta into dA by u of dA by x bracket square plus sin square theta plus cos square theta into dA by u of dA by y bracket square. But value of cos square theta plus sin square theta is 1 and therefore equal to dA by u of dA by x bracket square plus dA by u of dA by y bracket square. And therefore dA by u of dA by r bracket square plus 1 upon r square into dA by u by dA by theta bracket square equal to dA by u of dA by x bracket square plus dA by u of dA by y bracket square, which is the required solution of the given example. Okay, next example. If w equal to f of u comma v, where u equal to x square plus y square, v equal to 2xy, then show that x into dA by w by dA by x minus y into dA by w by dA by y bracket square equal to 4 into bracket in bracket u square minus v square into dA by w by dA by u bracket square. Solution. Let w equal to f of u comma v, where u and v are functions of x and y, u equal to x square plus y square, v equal to 2xy. First you can find derivative of u and v with respect to x and y partially, and therefore dA by u of dA by x equal to twice x, derivative of y square is 0, and dA by u of dA by y equal to twice y. Derivative of v with respect to x is twice y, and derivative of v with respect to y is twice x, and therefore here by chain rule derivative of w with respect to x nothing but dA by w by dA by u into dA by u of dA by x plus dA by w by dA by v into dA by v of dA by x. We can substitute the value of dA by u by dA by x and dA by v by dA by x, which are nothing but twice x and twice y. Putting this value we get dA by w by dA by x equal to twice x into dA by w by dA by u plus twice y into dA by w by dA by v. Also derivative of w with respect to y partially nothing but dA by w by dA by u into dA by u by dA by y plus dA by w by dA by v into dA by v of dA by y. But dA by u of dA by y is twice y and dA by v by dA by y is twice x. Putting this value we get dA by w by dA by y equal to twice y into dA by w by dA by u plus twice x into dA by w by dA by v, and therefore x into dA by w by dA by x minus y into dA by w by dA by y equal to x into this value of dA by w by dA by x minus y into this second bracket nothing but value of dA by w by dA by y. Then simplify we get 2x square into dA by w by dA by u plus 2xy into dA by w by dA by v minus 2y square into dA by w by dA by u minus 2xy into dA by w by dA by v. Then second term and fourth term are cancelled. From remains say first term and third term, and therefore 2x square into dA by w by dA by u minus 2y square into dA by w by dA by u. From both term we can take 2 as common, dA by w by dA by y u as common, in bracket remains x square minus y square, and therefore x into dA by w by dA by x minus y into dA by w by dA by y bracket square equal to, by squaring, square of 2 is 4 into x square minus y square bracket square into dA by w by dA by u bracket square. Now we know that a minus b bracket square equal to a plus b bracket square minus 4ab, and therefore you can substitute the value of x square minus y square bracket square using this formula. We get x into dou bar w by dou by x minus y into dou bar w by dou by y bracket square equal to 4 into value of x square minus y square bracket square is x square plus y square bracket square minus 4 times x square into y square into dou bar w by dou by u bracket square. Here a is same as x square, b is same as y square, and therefore x square plus y square bracket square minus 4 into x square into y square, and therefore equal to 4 into bracket x square plus y square bracket square minus 4x square y square is same as 2xy bracket square. But x square plus y square is given function u and 2xy is v, and therefore equal to 4 in bracket u square minus v square into dou bar w by dou by u bracket square, which is required solution. Okay, next. If z equal to tan inverse of x upon y, where x equal to u plus v, y equal to u minus v, show that dou bar z by dou by u plus dou bar z by dou by v equal to u minus v upon u square plus v square. Solution. Let z equal to tan inverse of x upon y, a function of x and y, and x equal to u plus v, y equal to u minus v. First we can find derivative of x with respect to u and v, and derivative of y with respect to u and v. We get dou bar z by dou by u dou bar x by dou by u equal to 1, dou bar x by dou by v equal to also 1, dou bar y by dou by u equal to 1, and dou bar y by dou by v equal to minus 1. Now here z equal to tan inverse of x upon y, you can find derivative of z with respect to x and with respect to y partially, and therefore dou bar z by dou by x equal to, we know the derivative of tan inverse of x is 1 upon 1 plus x square. Derivative of tan inverse of x upon y is 1 upon 1 plus x upon y bracket square into derivative of x upon y with respect to x. Derivative of x is 1, 1 upon y is constant term, therefore into 1 upon y. Then we can simplify here x upon y bracket square, that is x square upon y square, that is y square plus x square upon y square. We can simplify, we get y square upon y square plus x square into 1 upon y. Then y cancel, therefore remains y upon x square plus y square. Derivative of z with respect to x. Then derivative of z with respect to y. Derivative of tan inverse of x upon y with respect to y. First 1 upon 1 plus x upon y bracket square into derivative of x upon y with respect to y. At that time x is constant. Derivative of 1 upon y is minus 1 upon y square. Then simplify, we get y square upon x square plus y square into minus x upon y square. Y square cancel, remains minus x upon x square plus y square. And therefore, by chain rule, dou bar z by dou by u into dou bar equal to dou bar z by dou by x equal to dou bar z by dou by x into dou bar x by dou by u plus dou bar z by dou by y into dou bar y by dou by u equal to value of dou bar z by dou bar x is y upon x square plus y square. Dou bar x by dou by u is 1. Dou bar z by dou bar y is minus x upon x square plus y square into dou bar u of dou bar y of dou bar u is 1. Then simplify, we get y minus x upon x square plus y square. This is equation 1. Also, dou bar z by dou bar v equal to dou bar z by dou bar x into dou bar x by dou bar v plus dou bar z by dou bar y into dou bar y by dou bar v. Putting the values, dou bar z by dou bar x is y upon x square plus y square into dou bar x by dou bar v is 1. Dou bar z by dou bar y is minus x upon x square plus y square into dou bar y of dou bar v is minus 1. There is second term minus minus plus, we get y plus x upon x square plus y square. And therefore, dou bar z by dou bar u plus dou bar z by dou bar v equal to, by taking the addition, the value of first term is y minus x upon x square plus y square, and value of second term is here plus, the value of second term is here minus, value of dou bar z by dou bar x is here, we can take here plus sign, y plus x upon x square plus y square. Then here minus x plus x cancel, here y plus y twice y, that is twice y upon x square plus y square, here plus sign. It did minus sign, it is plus sign here. Therefore y plus y 2y minus x plus x cancel, and we get 2y upon x square plus y square. Now x square plus y square equal to x nothing but u plus v, and therefore u plus v bracket square, value of y is u minus v, therefore u minus v bracket square, taking the bracket square expansion, u square plus 2uv plus v square, and u minus v bracket square, u square minus 2uv plus v square, plus 2uv minus 2v cancel, we get u square plus u square 2u square, v square plus v square 2v square, and therefore 2 in bracket u square plus v square, this value of x square plus y square, and given that y equal to u minus v, and therefore dou by z by dou by u plus dou by z by dou by v equal to 2y upon x square plus y square. But value of y is u minus v, and value of x square plus y square is 2 in bracket u square plus v square. Then 2 to cancel, we get u minus v upon u square plus v square is required solution. Next, if w equal to f of x upon y, comma y upon z, comma z upon x, then show that x into dou by w by dou by x plus y into dou by w by dou by y plus z into dou by w by dou by z equal to 0. Sorry. Solution. If we can take w equal to f of u comma v comma t, a function of u v t, and u equal to, we can take x upon y, v equal to y upon z, and t equal to z upon x. Then we can find derivative of u v t with respect to x, y, and z. And therefore, first you can find derivative of u with respect to x. Derivative of x is 1 upon y is constant. Derivative of u with respect to y, x is constant, derivative of 1 upon y is minus 1 upon y square, therefore minus x upon y square, and derivative of u with respect to z is 0. Derivative of x with respect to x, 0. Derivative of v with respect to y, derivative of y is 1 upon z constant, and derivative of v with respect to z, derivative of 1 upon z is minus 1 upon z square, therefore minus y upon z square. Then derivative of t with respect to x, derivative of 1 upon x is minus 1 upon x square, therefore minus z upon x square. Derivative of t with respect to y is 0, and derivative of t with respect to z is 1 upon x, derivative of z is 1, and therefore by chain rule, dou by w by dou by x equal to dou by w by dou by u into dou by u of dou by x plus dou by w by dou by v into dou by v of dou by x plus dou by w by dou by t into dou by t of dou by x. We can substitute the value of dou by u by dou by x, dou by v of dou by x, and dou by t of dou by x. We get dou by w by dou by x equal to dou by w by dou by u into dou by u of dou by x is 1 upon x plus dou by w by dou by v into dou by v of dou by x is 0 plus dou by w by dou by t into dou by t by dou by x is minus z upon x square. We can multiply by x, and therefore x into dou by w by dou by x equal to minus x upon y into dou by w by dou by u. Here minus x cancel. If you multiply by x, then x cancel. We get minus z upon x into dou by w by dou by t, equation 1. Then we can find derivative of w with respect to y equal to dou by w by dou by u into dou by u of dou by y plus dou by w by dou by v into dou by v of dou by y plus dou by w by dou by t into dou by t by dou by y, and therefore equal to dou by w by dou by u into derivative of u with respect to y is minus x upon y square plus dou by w by dou by v into derivative of v with respect to y is 1 upon z plus dou by w by dou by t into derivative of t with respect to y is 0. Then simplify, if you can multiply this equation by y, we get y into dou by w by dou by y equal to, if you multiply by y cancel, remains minus x upon y into dou by w by dou by u plus y upon z into dou by w by dou by v. This equation 2. Again, dou by w by dou by z equal derivative of z with respect to z equal dou by w by dou by u into dou by u of dou by z plus dou by w by dou by v into dou by v of dou by z plus dou by w by dou by t into dou by t by dou by z. This derivative of w with respect to z. Then putting the values, we get dou by w by dou by u into derivative of u with respect to z is 0 plus dou by w by dou by v into derivative of v with respect to z is minus y upon z square plus dou by w by dou by t into derivative of t with respect to z is 1 upon x. Simplify. by multiplying z, we get z into dA bar w by dA bar z equal to first term 0 minus y upon z into dA bar w by dA by v plus z upon x into dA bar w by dA bar t. This is equation number 3. And therefore from equation number 1 and 3 we can take their addition. We get x into dA bar w by dA by x plus y into dA bar w by dA by y plus z into dA bar w by dA by z equal to, from equation number 1, value of x into dA bar w by dA by x is x upon y into dA bar w by dA by u minus z upon x into dA bar w by dA by t. From equation number 2, value of y into dA bar w by dA by y is minus x upon y into dA bar w by dA by u plus y upon z into dA bar w by dA by v. And from equation number 3, value of last term is minus y upon z into dA bar w by dA by v plus z upon x into dA bar w by dA by t. Then we can take here the first term is x upon y into dA bar w by, this term is plus here and this term is minus here. First and third term cancel. This second term and last term both are same cancel, and this y upon z and this minus y upon these two terms are the same, this term cancel, and therefore equal to 0. Therefore x into dA bar w by dA by x plus y into dA bar w by dA by y plus z into dA bar w by dA by z equal to 0, which is a required solution. One more example. If w equal to f of e raised to y minus z, comma e raised to z minus x, comma e raised to x minus y, then show that dA bar w by dA by x plus dA bar w by dA by y plus dA bar w by dA by z equal to 0. Solution. Let w equal to f of u, comma v, comma t be function of u, v, t, and u equal to e raised to y minus x, v equal to e raised to z minus x, t equal to e raised to x minus y are functions of x, y, z. First you can find derivative of u, v, w, t with respect to x, y, z, and therefore dA by u by dA by x equal to derivative of first term is 0. DA by u of dA by y equal to derivative of u with respect to y, derivative of e raised to y minus z is e raised to y minus z, which is nothing but u. Derivative of u with respect to z, derivative of e raised to y minus z is e raised to y minus z into derivative of y minus z is minus 1, therefore minus e raised to y minus z, that is minus u. Derivative of v with respect to x, derivative of e raised to z minus x is minus e raised to z minus x, because derivative of minus x is minus 1, that is equal to minus v. Derivative of v with respect to y is 0, and derivative of v with respect to z is derivative of e raised to z minus x is e raised to z minus x, that is v. Derivative of t with respect to x, derivative of e raised to x minus y is e raised to x minus y, that is t. Derivative of t with respect to y, derivative of e raised to x minus y is minus e raised to x minus y, because derivative of minus y is here minus 1, that is here minus t. And derivative of t with respect to z is 0. These are derivative of u, v and t with respect to x, y and z, and therefore by chain rule, dA bar w by dA by x equal to dA bar w by dA by u into dA by u of dA by x plus dA bar w by dA by v into dA by v of dA by x plus dA bar w by dA by t into dA by t by dA by x. Putting these values, dA bar w by dA by x is 0 plus dA bar w by dA by v into dA by v of dA by x, nothing but minus v, plus dA bar w by dA by t into dA by t by dA by x is t, and therefore we get dA bar w by dA by x equal to minus v into dA bar w by dA by v plus t into dA bar w by dA by t. Equation number t. Equation 1 is derivative of w with respect to x. Similarly, derivative of w with respect to y, nothing but dA bar w by dA by u into dA by u of dA by y plus dA bar w by dA by v into dA by v of dA by y plus dA bar w by dA by t into dA by t by dA by y. We can substitute the value of dA by u by dA by y, dA by v by dA by y, and dA by t by dA by x. We get dA bar w by dA by y equal to, first term is u into dA bar w by dA by u, second term is 0 minus t into dA bar w by dA by t. Equation 2. And then we can find derivative of w with respect to z. Apply same chain rule here. DA bar w by dA by u into dA by u of dA by x plus dA bar w by dA by v into dA by v over dA by y here, dA by z, dA bar w by dA by t into dA by t by dA by z. We can find derivative w with respect to z. Then we can put dA by u by dA by z, dA by v by dA by z, and dA by t by dA by z. We get dA bar w by dA by z equal to minus dA bar w by dA by u plus v into dA bar w by dA by v, equation number 3. Then adding equation 1, 2 and 3, we get dA bar w by dA by x plus dA bar w by dA by y plus dA bar w by dA by z equal to, from equation number 1 we can substitute value of first term is minus v into dA bar w by dA by v plus t into dA bar w by dA by t, plus from equation number 2 u into dA bar w by dA by u minus t into dA bar w by dA by t, and from equation number 3 minus u into dA bar w by dA by v plus v into dA bar w by dA by u. Then all terms are cancelled here and therefore equal to 0. Summary. In this chapter we can you can use 3 chain rules. Chain rule for 1 variable, 2 variable and 3 variable. First, when u is differential function of xy and xy different functions of t, at that time du by dt equal to dA by u by dA by x into dx by dt plus dA by u of dA by y into dy by dt. This chain rule first. Chain rule second here. Here u is differential function of x. Here w is function of u and v, and u and v are functions of x and y. We can find derivative of w with respect to x and with respect to y. That is dA bar w by dA by x equal to dA bar w by dA by u into dA by u of dA by x plus dA bar w by dA by v into dA by v by dA by x. Similarly, we can find derivative of w with respect to y. And this last is derivative of, here u of is function of u v w. U v w are functions of x, y, z. Then we can find derivative of u with respect to x, with respect to y, with respect to z, applied by chain rule. Then in this chapter we can use these 3 rules. If we understand these 3 rules, then we can easily solve the examples. Okay. Please like and share this video and subscribe my YouTube channel Parishram Maths Academy. Thank you.